Imagine you're driving through a busy city, looking for your friend's home on Lightbulb Avenue. You see her location on the map, but the actual streets have signs that only allow traffic to flow in one direction. The one-way street sign. A diode is the one-way sign for electrical circuits. The current is allowed to move through the diode in one direction only. Each diode has a positive end, the anode, and a negative end, the cathode. Current flows from the anode to the cathode, but not the other way around. Instead of traffic flow, we have electric current flow. In other words, energy flowing from a source, like a battery. In a closed circuit, this energy flows through wires and returns back to the source. And just like the arrow in the street sign, the symbol for the diode has an arrow to show the allowed direction of current. Very much like using a street map, electrical engineers use a schematic, which are documents showing how wires and components are connected. Most of us don't think of schematics when we turn on a flashlight or a light switch in our house. Just for fun, let's engineer a flashlight. A flashlight has one or more cells. Groups of cells are commonly called a battery, a switch, some wire, and a light bulb. Pretty much the way it's been for a century. Let's draw a schematic for this flashlight. Take a look at the schematic on screen. Our first circuit has a battery, some wire, the green lines, and a light bulb. The current, or the orange arrows, leaves the battery at the positive end and flows through the circuit. This is a closed circuit because there is a continuous path from the battery through the wire, through the light bulb, and back to the battery. Current flows, and the light bulb lights. Great! What if we reverse the battery in the circuit? The current flows out of the positive as before. We still have a closed circuit. The light bulb still lights. So where does the diode come in? First, we connect the diode to the battery, and the light bulb with the diode pointing in the same direction as the current flow out of the battery. The diode acts like a switch, which can be on or off. Current flows through the diode, and the circuit is closed. The light bulb lights. No surprises. As before, in our next circuit, we reverse the battery. This time, we have a diode in the current path. The light bulb does not light. The current wants to leave the positive end of the battery, but cannot pass through the wrong one way of the diode. This is an open circuit. No electric current passes through the circuit, and the light bulb does not light. This can save us from ruining our circuits by accidentally putting in the battery wrong. Let's look at how a diode works in a practical circuit. This diode circuit is called a rectifier circuit and is a step in converting AC, alternating current, to DC, direct current. Those plug-in wall adapters, sometimes called AC adapters for our cell phones and other electronics, have rectifier circuits in them. Alternating currents actually go from positive to negative directions. Direct currents, though, need to be in one single direction. To convert AC to DC, you have to take away that negative direction, which is just what diodes are for. In a half-wave rectifier, when the voltage is positive, the diode lets electric current flow. When it's negative, it does not. Take a look at the diagram on screen now, and you'll see what we're talking about. Voltage is in an alternating current above, and voltage is in a half-wave rectifier below, where negative signals are clipped. A full-wave bridge rectifier actually takes those negative parts and turns them into positive current, requiring 4 diodes. The details of this will leave for another lesson. Let's briefly explore some types of diodes. 1. The Zener diode. A Zener diode allows current to flow in the reverse direction if the voltage gets to a particularly high point. They are useful in circuits as voltage references and for voltage regulation, and in protecting some devices from damage. 2. The light-emitting diode, or LED. Light-emitting diodes are those little on lights on our keychains and other devices. In an LED, light is given off when current flows through the diode. Some LEDs emit visible light of various colors, while others emit infrared light. 3. The laser diode. The laser diode is like an LED, except the light is coherent, meaning the light waves are all at the same frequency and in phase. We find these diodes in fiber optic communications, laser printers, barcode readers, CD drives, and DVD drives. 4. The Schottky diode. Schottky diodes can switch on and off very fast. They're used in radio frequency applications and in power supplies. Let's review what we've learned. A schematic is a drawing showing how wires and electric components are connected. In a closed circuit, the electric current flows from the energy source, such as a battery, through the wires and components, and back to the source. Diodes allow current to flow in one direction only. The schematic symbol of the diode has an arrow indicating the allowed direction of current. In an open circuit, current will not flow because the current wants to leave the positive end of the battery, but cannot pass through the wrong one way of the diode. A common use of diodes is in AC-DC converters. A sine wave of voltage changes from positive to negative in a back-and-forth manner. A diode can be used to block the negative part. This is the basis for the rectifier circuit, which is a step in converting AC, alternating current, to DC, direct current. Types of diodes include Zener diode, allows current to flow in the opposite direction when a certain voltage is reached. Light-emitting diode, LED. Light is given off when current flows through the diode. Laser diode. Light is coherent, meaning the light waves are all at the same frequency and in phase. Schottky diode can switch on and off very fast.